மலையடிவாரத்துல பச்சை பசேல்னு இருக்கிற இடத்துல படிக்கிறதுக்கு நல்ல ஒரு ஃப்ரெண்ட்லியான என்வாயர்மெண்ட் தான் நம்ம SCAD Polytechnic காலேஜ்.
கல்வி சேவையில 36 வருஷம் அனுபவம் பெற்ற SCAD கல்வி குழுமங்களின் நிறுவனத்துல ஒண்ணுதான் இந்த SCAD Polytechnic காலேஜ்.
தரமான வசதிகள் நிறைந்த விசாலமான வகுப்பறைகள், எல்லா ஃபெசிலிட்டியோட லேப்ஸ், ஒர்க் ஷாப்ஸ், கேர்ள்ஸ் அண்ட் பாய்ஸ்க்கு செப்பரேட் ஹாஸ்டல், காலேஜுக்கு போயிட்டு வர பஸ் ஃபெசிலிட்டி உள்ளதுதான் நம்ம SCAD Polytechnic காலேஜ்.
மண்டல அளவிலான ஸ்போர்ட்ஸ்ல தொடர்ந்து 9 வருஷமா ஓவரால் சாம்பியன்ஸ் இவங்க தான்.
கோர்சஸ் ஆஃபர்ட்: சிவில் இன்ஜினியரிங், மெக்கானிக்கல் இன்ஜினியரிங், ஆட்டோமொபைல் இன்ஜினியரிங், எலக்ட்ரிக்கல் அண்ட் எலக்ட்ரானிக்ஸ் இன்ஜினியரிங், எலக்ட்ரானிக்ஸ் அண்ட் கம்யூனிகேஷன் இன்ஜினியரிங், கம்ப்யூட்டர் இன்ஜினியரிங்.
போர்டு எக்ஸாம்ல நல்ல மார்க் ஸ்கோர் பண்றதுக்காக ஸ்பெஷல் கோச்சிங் கொடுக்கறாங்க. ஒவ்வொரு செமஸ்டர் எக்ஸாம்லயும் ஸ்டேட் லெவல்ல ஃபர்ஸ்ட் 5 ரேங்குக்குள்ள ஸ்டூடண்ட்ஸ் எடுக்கறாங்க. 100% பிளேஸ்மெண்ட்டும் வாங்கி கொடுக்கறாங்க. சோஷியல் ஆக்டிவிட்டீஸ்லயும் நம்பர் 1 காலேஜ் தான் நம்ம SCAD Polytechnic காலேஜ். இந்த பெஸ்ட் காலேஜ்ல படிக்கணும்னா உடனே கால் பண்ணுங்க.
செல் 9942978528.
Good morning to one and all. First, I pray Lord Almighty for giving me this opportunity to arrange for this webinar. I welcome our chairman, vice chairperson and MD of our college for this webinar. I also welcome our honorable principal, vice principal and AO sir for their loving support and guidance in arranging this webinar. I also welcome our webinar speaker Mr.R.shiju Kumar, product design engineer, Firmtech Coimbatore, who is going to present the topic ARDUINO for electronic enthusiast. I welcome all our faculty members and all the students and all the participants of other colleges also. I welcome you all once again. Thank you.
And when we are going for serial peripheral interface, and this 13th pin will be used as a clock for SPI, that is serial peripheral interface, and so on. That is multi-purpose. This pin will serve for multi-purposes. And today's discussion will be concentrating only on the analog input pins and also as well as the digital IO pins, digital functions of the pins. And in the board, this is the microcontroller which we use, which is used in this board, and this is Atmega 328P. And this, when we come to this Atmega 328P, in this board, it uses a clock frequency of 16 megahertz, and this has a flash memory of 32 kilobytes as well as SRAM of 2 kilobytes and EEPROM of 1 kilobytes. And this is the pinout diagram for this microcontroller 328P. And one thing we should remember is each of the IO pins, that is whether it is analog or digital, it can give an output current of 20 milliamps at the most, and as well as an output voltage of 5 volts. So we should connect a device within this range. It should not draw more than 20 milliamps current, or it should not take more than 5 volt of 5 volt input. So these are the two precautions to be followed before we connect a device with this microcontroller or interface a device with this microcontroller or this Arduino board. So we can go to the first experiment, that is the blinking of an LED. This is the basic experiment with an microcontroller. So blinking of an LED. So here I have, this is my Arduino Uno board, and I have connected an LED with its anode to the 12th pin of the IO, that is the digital IO pin 12, through a resistor, as well as this cathode is grounded. This is the ground of the Arduino board, so I have used that ground for grounding. So now we should know what is the need for this resistor. Actually, this 5 mm LED will draw a current of that is maximum 20 milliamps current, and it requires only 2.2 volts. So what I like is it should draw only 10 milliamps of current. As far as my design is concerned, it should draw only 10 milliamps of current, and it should operate at 2 volt. So I have used a resistor there. So by using this formula, this V is the supply voltage. Here the supply voltage refers to the voltage available at the pin 12. That is a pin which we are about to connect our load. Here the load is the LED. So I am going to connect my that is LED in the pin number 12. So this pin number 12 can provide at most 5 volt, and of this 2.2 volt is required by your LED. So I wish that is it's 2 volt is enough for my LED, and I refer a maximum current of 10 milliamps. So with these values, the resistance will be 300 ohms, but the available, that is the resistor available in the market nearest to 300 is 330 ohms. So I have used a 330 ohm resistor here. So next, as per my requirement, I should make the LED blink. That is, it should be in on state for a specific interval of time, and then it should go to off state. That is my intention. So I should give a pulse as input to this anode of the LED. So initially the pulse should go high, and it should remain there for some specific interval of time, and I have fixed my interval of time as 1 second. So in Arduino, when we are going for 1 second, it should be written in milliseconds. So that is 100 milliseconds. After 100 milliseconds, I should again lower the pulse. That is, I should make the pulse to go low. So again, I will give a command to make the pulse low, and I want my LED to to be in off state for another 100 milliseconds. That is for another 1 second. So again, I will give a delay of 100 milliseconds. So like this, the process completes. And let us go and see how to program this using the Arduino. So to program this, I should first start a new window. So this is the Arduino IDE. This Arduino IDE, that is the installation of the Arduino IDE, I will explain at the end of the session. So I should open a new window. And the program which we write in Arduino is known as Sketch. So it contains two main parts. First, there is void setup of function part as well as void loop of function part. The things which are used as the setup, that is the initial setup, which is to be done once in our programming, should come under this void setup of part. As per our requirement, I should declare this pin number 12 as an output pin. So to declare that, the command is pin mode, and this pin number 12, comma, output. And every statement should be entered with a semicolon. This is the only one setup and only one setup required for this experiment. And next, the loop, that is, I want to make the LED blink continuously. To make the LED blink continuously, I should write a high value at the output pin. So digital write. Digital write of pin number. Pin number is 12, comma high. Again, the semicolon. And now I should introduce the delay. Delay of this delay will be given in milliseconds. 1000. And again, digital write. That is, now our output is high. Now I have to make the output low. So again, digital write. Again, the same pin number with low value. Semicolon. And after it has attained the low value, it should retain there for one second. So I have to introduce a delay. So this is what the program needed to make my LED run, that is the LED blink for 1 second. So next I have to compile this. If you are compiling this, it's okay, but in order to that is the flash the microcontroller, you should use this, that is the download or upload. To upload to the microcontroller, you should use this. So if I press this, it may take some more time. So before that, it will be asked for saving that. So already I have done this and I have made a video of this. So we will run that first. So here, see here, the LED blinks for 1 second. That is, this process continues. As you have that code inside the loop, the process continues. As far as the Arduino board is powered, this process will be continuing. So now again, I will come to the program. That is, I want to generalize this. Here I have given, that is the pin 12 as the output pin. and then this loop here. So now I wish to generalize my coding. That is constant integer LED pin. Instead of remaining the pin number, I give a pin, a variable name, a constant name to that pin. That is LED pin is the pin name now. So LED pin in this program, wherever we use the name LED pin, it represents pin number 12 of the Arduino. So let me copy this. So instead of using this 12, I should use LED pin. So the same case here also. Instead of using this 12, I can use LED pin. The advantage of this method is that is this advantage of this method is whenever we are going for that is the large programs, we will not be able to remain the pin numbers. We have to see it repeatedly. So to avoid that, we are going for this method, that is generalizing that pin numbers by a variable name or a constant name and assigning that name as the pin. So if you compile this, this will give the output, and this output will be same as what if you have seen already. Now, so in this case, we have used a LED, and this LED is controlled by this microcontroller. It makes the LED to blink. And now I want to interface a switch and momentary push button switch. So this is the circuit for that. I want to introduce a momentary push button switch, and when I press this switch, this LED will be on, and when I release it, it will come to off state. That is my requirement. So that is this momentary press button switch will have a contact closed till we press it. Once if we release the switch, this contact will be open. So my aim is to demonstrate that working. So in this circuit, I have taken this is the 5 volt as the 5 volt rail, and this ground as the ground rail or 0 volt rail, and I have used the switch here. So once by using this switch, I can control this LED based upon this input. So when we are connecting this switch, there is a problem. That is that is the tri-state or the floating state will be come into picture. So to avoid that, we should use a pull down resistor. So in this is the Arduino board. I have used this 5 volt to connect this switch, and in this controller I have used pin number 2 as the input pin. Input pin means it reads the state of the switch. When this switch is closed, this pin number 2 will be connected to 5 volt. And when the switch is open, the pin number 2 will be connected to ground. So low state. So if there is no resistor, what happens is this: when we are closing the switch, this will be the low resistance path. In the absence of the resistor, this will be the low resistance path when compared to the pin 2. So the current flows to the ground. That is, the 5 and 0 will be short circuited through the pin. No input will be obtained at the pin number 2. So to avoid that condition, we are using the pull down resistor. Usually we will use pull down resistor of 10 kilo ohms. So I have done my circuit here. This is the positive from the that is the positive or 5 volt supply. From the 5 volt supply, I have connected to the switch, and from that, then from the output side of the switch, I have connected a resistor and grounded it. And these two sides are internally connected. So it is equivalent to taking an point between the switch and the resistor. So I have taken that and connected it to the pin number 3 of the Arduino. As well as I have connected the output at pin number 4. Pin number 4 means it will be connected to the anode of the LED, and the LED is grounded by a current limiting resistor. So let us see the coding of it. I'll be taking a new file. So void setup of. So initially, before void setup, let me give the initial setups. That is the constants. Constant integer of integer. First, we have the button pin. Button pin means the push button pin. Button pin equals 3 because we have connected the button to the third pin of the Arduino. Then again, constant integer LED pin, and LED pin equal to 4 as per our design. And here, to read the value from that pin number 3, we use a variable, and that variable name is integer button stage. Integer button stage. And this integer button state is equal to 0. Initially, we assign that value to be equal to 0. And now we can put the code in the, that is the setup code. So we have to define the pin modes. Pin mode, and the name of the pin is button pin first. Button pin, and we should declare this as the input pin. Semicolon. And next one is LED pin. And LED pin is the output pin. So these are the two initial setups that we needed. And next, the loop part. And our condition is whenever the button is pressed, the LED should blink. So first we have to read the button input. So we have to read that button input and store it in the variable button state. Already we have declared that variable button state. So button state is equal to, here we read and we use a function digital read off. Digital read off. And what should we read? We should read the button pin. So digital read off button pin. Colon, semicolon. And now we should check the state of that button pin. If button state is equal to button state is equal to high. So if button state is equal to high, then the LED should be switched on or turned on. So we have to write digital write LED pin high. So this is one condition. So if this is not satisfied, that is if button state is high, then LED pin should be high. If button state is low, then LED pin should be low. So for that we can use an else condition. Else if else digital write LED pin low. So this is our program. That is, initially it reads the value by using the digital read function from this button pin, and it converts that value. That value will be stored in the button state, and it converts that value. To convert, we will be using the double equal to. So this is then comparison operator. So if button state is equal to high, then this statement should be succeeded. So digital write should be, the digital write of LED pin should be high. So if this condition is false, then LED pin should be low. So the same procedure, if we can compile this and upload it to the processor, so or to our Arduino. So our output will be, you can see the video here. So see here, once by releasing the button, the LED goes off. So when it is pressed, it is in on state. That is the condition. So now let us go for the next part. So here I want to control this LED in such a way that for the first press, the same circuit, there is no change in the circuit, but there will be some change in the codings. When I press the LED for the first,
Manat sir?
மேடம் சொன்ன வர சார் லெஃப்ட் ஹேண்ட் எனக்கு என்ன தெரியல பாப்போம்.
ஆமா சார்.
சுஜா மேடம் சாருக்கு ஃபோன் பண்றீங்களா?
சுஜா மேம்?
சரி நானே ஃபோன் பண்ணிடுறேன் மேடம், நானே ஃபோன் பண்ணிடுறேன் மேடம்.
உன் நம்பர் இருக்கா சார்?
இருக்கு மேடம்.
I want to toggle the LED by using the switch. So for that, I am going for the altering the program itself. No changes in the hardware. The hardware remains the same as the previous state. And now I will be changing the code alone. So when pressing the switch and we come across an difficulty, that is based upon the physical structure of the switch as well as the force with which we press the switch, bouncing occurs inside the switch. That is, this is the instance at which we press the switch. What we think is the switch is now on. So in between this, that is before it comes to a stable state or high state, it goes oscillating between the high state and low state for some interval. So this is known as bouncing. This bouncing will be easily identified by the microcontroller and it will give a false output other than what we expect. So to overcome this, we should use switch debouncing. And the switch debouncing is done with the help of the software. That is, we will be inserting some delay inside this, and by that delay we will be controlling the bouncing of the switch. Let us see it in the program. And this is the program for switch debounce. The same program, initially we have assigned the constant integer button pin 3, that is press button is connected to pin number 3 and LED is connected to pin number 4. And initially we assign an LED state, that is a variable name LED state. This LED state is initially low. That is, when we start the program, this LED will be in off state. And next variable is button state. That is what is the button state is. That is the value read from the button or the reading from the button. And here we use last button state. We want to see the previous state of the button. So for that, we are using another one variable name last button state. And this is also assigned with value low. So unsigned long integer, that is, we are using the time to calculate the bouncing time. So it may be of that is, if you are storing it in integers, it will not be feasible. So we are using unsigned long. And next we go for the setup. And here I have used the serial begin off. There is a facility in this Arduino, that is, we cannot debug the codes by using some debugging methods. The one and only method is to use the serial monitor or the serial plotter. That is, to know the inputs, whether the input is coming or not, we should use these two methods. No other method is possible. So to use that, to make you familiar with that, I am using the serial begin off. And this is the baud rate at which this serial begin will be communicating with the serial monitor. And next, pin mode. Pin mode is equal to button pin is button pin as input and pin mode of LED pin as output, as in the previous case. And this digital write of LED pin is equal to LED state. That is, LED state is equal to low and LED pin is equal to 4. So this LED will be in off state initially. These are the initial setups which we do with this experiment. And now in this loop, first one is we are reading the button pin. So digital read of button pin and storing it in a new variable reading. This reading is a new variable which stores the status of the button pin, whether it is connected to 5 volt or whether it is connected to 0. So this will be fed as input to this variable reading. In case if this reading is not equal to the last button state, previously the button state is low, this last button state is low. If it is not equal to the previous button state, what it reminds us is someone who has pressed the switch. Someone has pressed the switch. So once the switch is pressed, the time instant at which this read in the switch is pressed should be transferred to the last debounce time. This millis of is a function in this Arduino which will give the time at that instant right from the starting of the program. That is the time from the starting of the program to the instant at which we use the millis of function. So that much time in milliseconds will be stored in the last debounce time variable. And now we have to check whether this time, that is after some instant, again we are checking. So if this millis of minus of this already stored last debounce time is greater than delay time, our delay time is 50 milliseconds. We already fixed the delay time to be 50 milliseconds. If it is greater than 50 milliseconds, then we assume that it is not bouncing, it is someone who has pressed the switch. So if it is less than 50 milliseconds, then it will not respond. If it is greater than 50 milliseconds, that is the debounce delay, it will respond. And now we store the reading. That is, now we check the next condition. That is, if the reading is not equal to button state. Already this button state is low. That is button state, not okay. So it compares it with the previous button state. If it is not equal to the previous button state, then it updates the button state with this reading, new reading. And if the button state is high, if the new button state is high, this LED will be toggling. That is, LED state is equal to not of LED state. Already if the LED is in off state, now the LED will comes to on state. If it is already in on state, then it goes to off state. So we have to write this LED state as output. So digital write of LED pin of LED pin comma LED state. Now we have to update all these values. That is, we have to update this value to the reading. That is the last button state, and we end the program. Let us go for its demonstration. See here, this is the button which I have used. So once initially the LED is in on state, and now I am pressing the LED button. So after releasing that, it goes to off state. But the next press, it again comes to on state. Like this, we can toggle the LED by using this program. So this is one case. That is, I have toggled the LED by using the button. So now my next aim is to read, that is the control an electrical device with the relay. So before going to this is the schematic of that circuit. So here I will be using the button also, but I haven't shown it in this circuit. That is, when I press the button, initially in the previous case, when I press the button, the LED comes to on state. But in this case, when I press the button, this bulb will glow. This bulb is connected to the 230 volt AC supply, and our controller works with 5 volt DC supply. And the relay is the interface between this AC and the DC. You just understand this circuit. That is, the neutral of the AC is connected directly to the switch, and the phase will be connected to the relay's common point. And from the normally open point, it is taken to the bulb. And here we have 3 inputs from the controller side. This will be the 5 volt, ground, and the signal. This is the ground, 5 volt, and this signal. The signal will energize the coil of the relay. The signal is from this Arduino controller. I have taken it from the pin number 10 of our Arduino controller, and this signal, that is a signal which is less than 5 volt, will energize the relay of the coil of the relay. Already this relay is coil is powered by using this 5 volt and the ground from the Arduino itself. Here the relay module which we use is the 5 volt relay module. Before going to this, we should have a simple understanding of this relay. This is what the relay looks like. This is the normally closed terminal. This is the normally open terminal. And here we may have 3 points. That is the coil, that is coil 1, that is the two ends of the coil, as well as the common point. To these 3, that is the to this coil point 1 and 2, we will be giving the inputs. See here, this is the relay, and this relay coil will be connected between the VCC and the ground by using a driver circuit. And is here for driver we are used the transistor. So if we give a pulse to the base of the transistor, the base emitter junction will be forward bias as it is an NPN transistor, and this starts conducting. As this base emitter starts conducting, that is the collector current also flows through this, so that the coil in the relay will be energized. So once the coil in the relay is energized, this normally open and normally closed position of the relay changes. We have connected our bulb to the normally open position. Once the relay is energized, the common will be in contact with the normally open point, and just the circuit will be closed and our light will be on. So this is the basic behind the operation of the relay. And now we can go for this program demonstrations. That is the so here the switch I have used. I haven't made any changes in the circuit. I have just connected a relay and a bulb. That's all. In the previous program, I have just connected a relay and a bulb. So when I press this switch, the bulb comes to on state, and if it is in on state, it goes to off state. So this is the relay which I have used, a 5-volt relay. Okay. And my next aim is to replace the switch by an sensor or a third value, that is an LDR, that is a light dependent resistor. I am introducing a light dependent resistor in my circuit, by which if this intensity of the light falling on my LDR goes low, this light should be on. That is, my bulb should come to on state. That is, at high intensity of the light, this relay should be in off state, and with low intensity of light falling on this LDR, it should come to on state. So here I have used the LDR, and while using the LDR, it forms an voltage divider circuit, and we will take the input to this controller, and this input to the controller should be fed to the analog input. So this is A0 is the analog input at this point, and this analog input is taken from the resistor and the LDR meeting points. So meeting points, and this 5 volts. This 5 volt is connected to one side of the LDR, and the resistor side is grounded. That is, the LDR will be connected to 5 volt, a resistor, and through the resistor it will be grounded. And in between, that is the point at which this LDR and the resistor is connected. At that point, we should take the output and feed it to the analog input. In the previous case, that is in case of switch, we connected that input to the digital pin, and now we are connecting this output from the LDR as input to the analog pin. Based upon that analog value, our relay will be switched on or switched off. That is, the operation of the relay will be purely based upon the value of the LDR. And this LDR can have the value 1024 if the light is in full intensity, and it will have the value 0 when this light is, so there is no light. So as we are using this 10-bit ADC, 2 power 10 is equal to 1024, we can have the values from 0 to 1023 as the input to this analog pin A0. So we can go for the program. This is the hardware, and there is no change in this relay connection. That is, we have connected this to the 230 volt supply. This neutral is connected directly to the bulb, and the phase is connected to the common point, and from the normally open point we have connected to the other terminal of the bulb. So the only change is we have introduced an LDR here. We have removed all those things, LED and as well as the push button switch. So in place of push button switch, we have replaced it with an LDR. So for automation, based upon the value of the LDR, our relay will be working. Let us see the program first. So this is the program for LDR in Arduino. Okay. So see here in the program itself, I have done some changes. That is, A0 is the analog pin 0. So this constant integer LDR pin is connected to A0 pin, analog 0 pin of the Arduino, and this relay is connected to pin number 10. And I have fixed some threshold value, that is analog threshold of 500. That is the based upon the value fed from the, that is obtained from the LDR, we may get some values from 0 to 1023 on the analog pin. Of this, I have fixed 500 as my threshold value. If the value is below 500, my relay will operate and light will be switched on. That's my condition. And I have given the serial begin to test these outputs. That is the output of the LDR on my serial monitor. So this is the case. So analog value. See here, I have given that is the analog value is the variable used to store the input from the analog pin, that is from the LDR pin. So here we have used the function analog read off. In the previous case, when we are pressing this switch, we use the digital read off function, but now we are using analog read off LDR pin. And serial print will print the value on the serial monitor. And in this line, I am comparing this analog value with the analog threshold. If analog value is less than analog threshold is 500. If this value is less than analog threshold, then this relay pin should go high. That is, the relay should be energized. Else, if this is not the true, then the relay should be switched off. That is the de-energized. This is the condition what we see. So I have already done this experiment, and I have stored that video recording. Let me play that. See here, this is the LDR. So to make it dark, I am immersing a cap on it. When the cap is immersed on it, automatically the bulb glows. So when removing this, it gets high brightness and the bulb comes to off state. That's its working. So next one is interfacing of LCDs. So in case of interfacing of this LCD, the two methods can be done: 8-bit interfacing or 4-bit mode. So in 8-bit mode, we will be using all the 0 to 7 data bits of the LCD. Actually, this is the LCD pin. This is the ground, VCC, and to control the display contrast, we'll be using a potentiometer of 10K pot, and this is register select, and this is read write enable. Usually we will be writing to the LCD, so this read write enable will be always connected to the ground potential, and this enable should be connected to the high potential, and this backlight anode and cathode should be connected to the plus 5 volt and 0 respectively. This is how we have connected that. So let us go for the demonstration part, and along with that we can see the ultrasonics also. So because I have done the experiment for this LCD and ultrasonics as a single experiment, so this ultrasonics means it sends the waves, and when the waves strikes the object, it reflects back. Based upon the time taken for reflection, it will calculate the distance. And while calculating, we'll be using some of the properties, that is the speed of the ultrasonic wave, which is equal to 340 meter per second, or 0.034 centimeter per microseconds. So here I have connected this LCD as well as the ultrasonic sensor to the Arduino board, and let us go for its coding. So I will explain the working along with this code. See here, actually to make the LCD work, we should have a library. We can download this library and add to the Arduino for Arduino Sketch. So after adding that library to that our software, that is in our system, we should include this as a header file. So actually the name of that header file is liquidcrystal.h. We have included this as we are including in C programming, and then we have initialized something, that is the pin numbers, that is RS pin of the LCD should be connected to the pin number 11 of the Arduino. Enable pin of the LCD should be connected to pin number 12 of the Arduino, and D4 data, we are using 4-bit mode, so D4, D5, D6 and D7 should be connected to 2, 3, 4 and 5th pin of the Arduino respectively. So next we are calling that is the object. We are declaring the object LCD. LCD crystal is a class which is defined in this LCD crystal, liquid crystal header. So we are declaring the and in this int trigger pin. Trigger pin is the pin of the ultrasonic sensor, and this trigger pin is connected to the pin number 9 of the Arduino, and echo pin is connected to the pin number 8 of the Arduino. So here we are using the floating point values of duration microseconds as well as distance in centimeters, and in this setup we are using serial begin of LCD begin 16,2. That is, this is the command to initialize the LCD. So in LCD is the object, and this is the method to begin it. So LCD dot begin of 16,2, and this 16,2 represents the 16 cross 2, that is 16 columns and 2 rows LCD. And LCD set cursor of 0, 0. That is, this cursor should be set at the first value corresponds to the column value. That is the 0th column, 0th row place. And at that point, at the 0th column, 0th row, we should print the words Arduino. And next, for the second line, we are writing this Firmtech at the position in the second column of the first row. So these are the initial setups which we are doing, and then we are declaring the trigger pin as the output pin and echo pin as the input pin. That is, the trigger pin sends an 10 microsecond pulse to the output, and the echo pin receives a signal based, that is, it sends the signal to the Arduino based upon the time interval taken by the, that is the ultrasonic waves to come back and reach the echo pin. So based upon the time only, the distance is calculated. So void loop of digital write off trigger pin. This is the part at which the 10 microsecond pulse is generated and sent out. And this is the duration in which there is the pulse is measured. That is, this will be measured until this that is the echo comes back. And this is the point at which we are calculating the, that is the distance. That is, the distance is equal to 0.017 into duration. That is the duration into speed divided by 2. That is, this is 0.034 centimeter per microsecond is the time taken by the waves to strike the object and come back. But we want the distance of the one side. So we will be divided by 2 and it may get 0.017. So from this, all these values, we will be calculating the distance in centimeters. These are the commands to display the distance on the LCD as well as the serial monitor. Let us go for its demonstration. So it's already displaying some distance. Let us see what happens. I have moved. This is my obstacle now. I have used a box here. It is almost equal to 14, that is 13.79. Small error is there, but almost accurate. And now it is almost near to 8. 8.3. So this is how we measure the distance by using the ultrasonic sensors. So again, we can use this LC, that is the Arduino, to control a servo motor. That is the servo motor which I use is SG90, which is a very small servo motor. And the servo motor has 3 inputs. One is from the pulse, that is from the microcontroller, which controls the angle by which the servo motor should rotate, and other 2 pins of the positive +5V and the ground. And I am controlling the servo motor by using a potentiometer. So what I do is I get the analog input from the potentiometer, from the center tapping of the potentiometer as input to the analog pin, as well as the potentiometer's other 2 sides will be connected to the +5V and ground respectively. So based upon the turn which we make on this potentiometer, the change in the resistance value, the analog value will be changing. So based upon this analog value, or that is the rotation of the servo motor will be changing. Let us go for the demonstration part. So before that, we can see the program. So this is the case. So here also we should include the servo.h header file, or we should download it and add it to this to our program. So I'm connecting this servo to this analog pin A1. Analog pin A1. In the previous case, I connected that analog, that is the analog, to the A0, and here I have connected to this analog pin A1, and there is servo, that is the control signal to the servo is from the pin number 13. Pin number 13 is a PWM pin. So this PWM will be changing the value of the servo. So here, based upon the potentiometer reading, that is analog read of A1. Analog read of A1 will read the potentiometer reading. So that value will be mapped into 0 to 180 degrees. And in my case, the servo will be rotating from 0 to 180 degrees. So this value from 0 to 1023 will be mapped correspondingly to 0 to 180 degrees. And then corresponding rotation will be seen at the output. So we can see that demonstration. So by changing these values, this servo is rotating. See here, based upon these rotations, this servo's angle is also changing. Okay, now I will say about the installation of this. That is, I conclude the technical session with this, and now I will be showing how to install this. So to install this Arduino, we can go to arduino.cc.en, or you can just go to the Google search, download Arduino. If you search download Arduino, you'll be directed to the first page. That is arduino.cc, and in that main source, what I have used is Arduino IDE. So we can use the download Arduino IDE. And from that download Arduino IDE, you should download for Windows. That is based upon your operating system. You can use for Windows 7. So once you give this, you will be directed to a next page. And here you can just pay something or get that as is a freeware, or you can click this just to download. If you click this just to download, that is, it will download it to some specific location where we wish to download the program. And from there we can install it. Once you install this, you will get this icon here, that is Arduino. And by opening this, you can write the program, or you can start with the program, start with programming, or write your sketch here. So as I am opening for the second time, the last program will open first. So what I should do is I should go for a new file and close this last file. Okay, with this I conclude the session, and I wish to thank the management authorities of SCAD Polytechnic, the principal, the coordinator for this webinar, the staffs behind this webinar, all the participants and students. Good evening to all.
Manas sir.
Ma'am, start பண்ணுங்க.
Okay, sir. Now this is the time for vote of thanks. I am Selva Kalyani. I am going to deliver vote of thanks now. First, I would like to thank our chairman sir and vice chairman ma'am for allowing us to organize this webinar today. Thank you, chairman sir and ma'am. Next, I would like to thank our MD sir. Thank you, sir. Next, I would like to thank our resource person, Mr.R.shiju Kumar, product design engineer, Firmtech, Coimbatore. Thank you, sir. Thank you for your valuable presentation, sir. Next, I would like to thank our assistant general manager and principal, Mr. J. Manimaran, for his support. Thank you, sir. Next, I'm very glad to thank our vice principal, Mr. Sahaya. Thank you, sir. Next, I would like to thank our AO sir, Mr. K. Murugan. Thank you, sir. Next, I would like to thank our media team and coordinator of this webinar. Thank you. Last, I would like to thank all the participants of today's webinar. Thank you. Thank you, one and all. Dear participants, please fill the feedback link in the chat box. In order to receive a certificate in your mail ID, please fill the link in the chat box. Feedback link in the chat box.
மலையடிவாரத்துல பச்சை பசேல்னு இருக்கிற இடத்துல படிக்கிறதுக்கு நல்ல ஒரு ஃப்ரெண்ட்லியான என்வாயர்மெண்ட் தான் நம்ம SCAD Polytechnic காலேஜ்.
கல்வி சேவையில 36 வருஷம் அனுபவம் பெற்ற SCAD கல்வி குழுமங்களின் நிறுவனத்துல ஒண்ணுதான் இந்த SCAD Polytechnic காலேஜ்.
தரமான வசதிகள் நிறைந்த விசாலமான வகுப்பறைகள், எல்லா ஃபெசிலிட்டியோட லேப்ஸ், ஒர்க் ஷாப்ஸ், கேர்ள்ஸ் அண்ட் பாய்ஸ்க்கு செப்பரேட் ஹாஸ்டல், காலேஜுக்கு போயிட்டு வர பஸ் ஃபெசிலிட்டி உள்ளதுதான் நம்ம SCAD Polytechnic காலேஜ்.
மண்டல அளவிலான ஸ்போர்ட்ஸ்ல தொடர்ந்து 9 வருஷமா ஓவரால் சாம்பியன்ஸ் இவங்க தான்.
Courses offered: Civil Engineering, Mechanical Engineering, Automobile Engineering, Electrical and Electronics Engineering, Electronics and Communication Engineering, Computer Engineering.
போர்டு எக்ஸாம்ல நல்ல மார்க் ஸ்கோர் பண்றதுக்காக ஸ்பெஷல் கோச்சிங் கொடுக்கறாங்க. ஒவ்வொரு செமஸ்டர் எக்ஸாம்லயும் ஸ்டேட் லெவல்ல ஃபர்ஸ்ட் 5 ரேங்குக்குள்ள ஸ்டூடண்ட்ஸ் எடுக்கறாங்க. 100% பிளேஸ்மெண்ட்டும் வாங்கி கொடுக்கறாங்க. சோஷியல் ஆக்டிவிட்டீஸ்லயும் நம்பர் 1 காலேஜ் தான் நம்ம SCAD Polytechnic காலேஜ். இந்த பெஸ்ட் காலேஜ்ல படிக்கணும்னா உடனே கால் பண்ணுங்க.
Cell 9942978528.